Swayam Prabha. Digital India. Educated India.
Good morning. Today, as a part of fabrication technology involved in vacuum systems, we will take you through a journey of welding techniques, brazing techniques, gluing techniques, so that you know how to attach various components, various couplings and various peripherals along with chambers, along with piping network, so that you will get an overall system. So, fabrication is a very important step in vacuum systems development. We have already seen in the last 3 lectures about materials involved in making the vacuum systems. We have seen chamber design, thickness calculations, etc. We have also seen various types of components like valves, flanges, couplings. When you couple all of them along with the major component, of course, chamber, following certain design criteria which we have explained in the second class, last 3 classes. First class was materials, second class was chambers, third class was components. Now, we try to do all those things with our fabrication fundamental knowledge by welding, brazing, etc. Then a system will come. But in vacuum systems, it is not just somehow make it. Why you have to keep track of several other aspects, that is degassing, leak, permeation, corrosion, strength and compatibility. Finally, within your budget it should come, and also most important is it should look little beautiful. Vacuum systems, there are companies who make it very nice looking, because everything will be finally in some panels with control systems, etc. So, the overall system, vacuum system will look like a beautiful cubicle box with lot of IoT controls, everything, but inside all this hardware will be there with very high quality polishing inside the vacuum side. So, so many aspects are involved in vacuum system design, not just somehow couple everything. Okay. So, these things we will consider while discussing the hardware aspects of it, like welding, brazing, cleaning, etc. So, in this particular talk, what we will be focusing on introduction to the joining techniques basically, though it is assembling techniques later, welding techniques, brazing techniques, gluing techniques, and how do you make your jobs clean before welding, after welding. With all this knowledge and with a very good welder with you, I am sure if you make a startup in vacuum chamber design or making manufacturing to suit some applications, you will be able to get a very good business. You do not have to make pumps, you do not have to make instruments, etc. If you are very good in chamber design or small couplings, but if you know the intricate aspects like leak detection, outgassing, etc., by going through this course, when you become a qualified, certified person, I am sure you will be able to succeed in vacuum technology. A chamber, normal chamber, if it costs X, a highly polished vacuum chamber with proper weldings will be 10 times costlier. So, if you are very careful and if you can minimize various purchases and maximize the quality of chamber manufacturing, you will get a very good margin. This is what I want all the budding entrepreneurs to keep in mind, particularly engineers after some management qualities with good amount of computer software, with good amount of design capabilities and advanced materials. If you are having good knowledge and metallurgical processes, I am sure you will be able to get a very good life. Okay. So, this idea you should keep at the back of your mind, and also you should go through the earlier 3 lectures, that is materials, and components and chamber designs. These are I think 26, 27, 28 lectures. Now, today we will be doing 29th lecture. In the 30th lecture, we will cover all these things together with respect to other foreign aspects like degassing or connectivity or pump down issues. They are not in the manufacturing or fabrication issues, but they are related, because unless we get finally the purpose for which all these things are made, it is of no use. So, 30th lecture of this module, which is covering chamber design, materials, components, fabrications, I want to keep it to give you some ideas, tidbit hints, so that an engineer or a manager or a technician or even a cleaner will become a better manager, better engineer, better cleaner. This is what my aim in this module. So, that we will be looking after in the next lecture. Now, let us come to the present lecture. In the last class, 2 classes or 2-3 classes, we have already discussed chambers, materials for vacuum systems, because today's world is advanced materials. For example, semiconductor technology, 30-40% of the cost is to make a semiconductor initially from the nature, from the sand. You have to bring it to high purity silicon. So, there is a lot of vacuum chambers, vacuum associated equipment necessary for doing that, along with heat transfer fundamentals and washing with a very high quality water, and also trying to control different parameters without any oxygen, because otherwise silicon becomes silicon dioxide. So, original source may be silicon dioxide like sand. From there we try to remove oxygen under controlled atmospheres and to make a silicon. Again, when you are trying to dope something and make some devices like active and passive devices and connect them to make chips, we should not again make it to silicon dioxide. So, like that, so many aspects are there intricate, but they are all related to chamber design. They are all related to the fabrication of a high quality vacuum system within which you are doing all this. So, quality of a final product, whether it is IC chip or a metallurgical component or a space technology or a satellite testing, everything depends on chambers, chamber fabrication technologies and assembling couplings and variety of intercoupling ideas. This you should keep in mind. Vacuum technology apparently looks like, oh, what is there, you make a coupling. No, it is not like that. Few parts per million impurities matter in semiconductor. Similarly, few micrograms of gas leaking into ultra high vacuum chamber immediately will bring the vacuum from 10 power minus 10 torr to minus 7 torr. High pressures, grams of gases are required, okay, which go out or become positive pressure, and even if little bit leaks out, we may not care unless it is a dangerous gas. But in low pressure applications, vacuum applications, if there is a small leak, we cannot say it is a small leak, in such a big system a small leak, good enough. Just like a small corona molecule can kill a big body. So, it's like that. These are microscopic molecular effects are very stringent and applicable in vacuum technology. It is micrograms of gas, it is not even gas, molecules. So, while doing all these fabrication issues, you should have to keep track of internal leaks, external leaks, flanges, how are they going to couple. If you just make a bad welding, then it is of no use, even if you have very costly pumps. So, this is what we have to identify the appropriate fabrication method, so that it depends on the level of vacuum that we are dealing with. If it is a high vacuum, one style, if it is ultra high vacuum, another style. And while doing that, there are some standard components available across the market. So, you do not have to make everything in the world in your company. You can purchase certain things, because they are following certain international standards, which you have seen in the last lecture. So, you should be intelligent enough what should be fabricated in your company and how best you can purchase pumps with the conductance calculations, with proper piping, how do you maximize the pumping efficiency, and how do you minimize the leaking chances, and how do you minimize the outgassing issues. While fabricating, you should keep all those things in your mind. And cleaning before fabrication, before welding and after welding is very important. And if you do not give attention to that, you will end up in very nice looking apparently, but it is a leaky system or outgassing system, and the application demands -9 tar. With great difficulty you have removed 99.9999%, but it is still 10 power -7 tar. You have spent already 2-3 days, but you made some mistakes in either seals or materials or welding somewhere, and very good pumps are available, AC rooms, everything good, vacuum is not coming, process is not starting, output chips are not coming. So, vacuum technology plays a very important role through a high quality fabrication techniques based on some standard equipments available, based on some standard designs to minimize the wall thickness, etc. You have to keep track of all these issues. Well, instead of talking about welding, brazing, why I am talking like this? Because these welding, brazing things you can get easily from any book, even routine mechanical engineers do, nothing great we are doing separately for it, excepting that some specialized things are there like electron beam weldings and plasma weldings, which are not normally used unless it is a very fine welding in high pressure side. But in vacuum side we use all sorts of advanced welding techniques. Welding is not just a small TIG welding that we see in day to day world for our household welding, etc. So, that is what you have to see, and cleaning is not just some cleaning with some soap water or water. It has to be done with deionized water, then purging with high pressure pure gas, then ultrasonic cleanings. All these things have to be done to remove dust and water or various other contaminants, etc. So, finally, when you are assembling things, what are the components need to be introduced and which type of technology you have to take, whether it is brazing or this one, it all is decided by the level of vacuum and the purity requirements. Sometimes -5 tar is required for 2 applications, but one place you cannot withstand even parts per million oxygen, but other place -5 tar is meant for -5 tar. For example, a thermos flask like this, it is 10 power -3 tar, good enough thermal vacuum, one inner vessel, outer vessel, that is all, convective heat transfer. They do not care whether the molecules are hydrogen or nitrogen or anything, that much is okay. Residual gas conduction should be as small, heat conduction should be as small as possible. But same 10 power -3 tar, if it is a molecular distillation, even if parts per million some other molecules are there, then your drug will be a poison. So, chemistry matters some places, physics matters some other place. You have to decide the components and fabrication technologies accordingly and plan the accessories and components accordingly. Well, I have spent a lot of time in introducing the importance, etc. Let me be little faster to complete my talk in limited time, but what I told you is very important, because welding, brazing you can find from any Wikipedia or any textbook, like lap weldings, butt weldings and corner weldings. These are the words we have been listening since long, since 100 years, these are slowly getting developed. So, a typical vacuum chambers, particularly ultra high vacuum, are looking like that. Why I am showing UHV chambers? If you are used to UHV chambers, you can easily make HV chambers, you can easily make normal chambers. If you are used to deciding high quality stainless steel with minimum thickness with proper design for stress calculations, etc., you can easily purchase mild steel and make chambers, etc. So, you should be mentally prepared to the most difficult aspect of it, where even micrograms of gas are not allowed to leak in. So, welding should be perfect. So, when you concentrate on welding techniques of such chambers, what we need to keep in picture? Full penetration of the welds is required. In fact, recently very high costly chambers are manufactured from an ingot itself by scooping out the material, totally avoiding weldings, everything inside. That means, take a big rock, make a temple and make a hole and make a idol like that. So, that is monolithic structures, they are coming up in a big way in semiconductor technology, but it is very costly, lot of material may be wasted, but still it is worth, because one time. But normally speaking, there are ultra high vacuum chambers as we show here. which are having various components, and from a sheet metal you make a chamber, whether it is a cylindrical or spherical, attach all those things, lot of welding things are involved. Selection of components and seals and all we have already covered. If you want, you can go back and again come here. Then as far as possible, the welder, who is the most important person in a ultra high vacuum chamber, you should pay him sufficiently good salary. If he is psychologically little tired, welding efficiency will be bad. All the weld efficiency that we are using 0.8, 0.7 in design issues in ASME section 8, I would say welder's efficiency also there, because if he makes one mistake, or if his hand is shaking, or even if it is a robotic thing, if he does not know how to operate, he makes some small mistakes, gone. Okay. And single pass he should do it, that is another thing. You cannot do for some time and go out and have a tea and then come back, because that starting point will be difficult. The torch has to move continuously, to move a continuous one circle, otherwise there will be discontinuities in that, which is very dangerous. It creates pockets of gases. Okay. So, single pass welds are very important. Suppose you want very high strength, you can increase the strength from outside. Outside you can have some skip welds here and there, that need not be continuous, but inside vacuum side only you should always weld it, because vacuum we are concentrating. From that side, the first surface itself is welding. Preferably entire thing is monolith, but that is not possible. Some pieces have to be joined, but that joining you should do from vacuum side. So, welding should be always done from the vacuum side. Once we decide the single pass and some skip welds for mechanical strength and continuous inside welding and proper cleaning of these things before welding, then you decide whether it is a butt weld or a lap weld or a corner weld. Okay. So, if it is a butt weld, full penetration can take place like this, that is correct welding, whereas a discontinuous penetration, that is very bad. Sometimes a pocketed gas things may be there, it may be micrograms, but at 10 power minus 7 torr it creates trouble. And for increasing strength on both sides you are trying to weld like this, and it penetration is not full, there is a small gap which is a permanent small room sitting within your flange materials, two flanges when they are joined, this side vacuum, the other side atmosphere. But this gas slowly will come out, and if there is some small amount of corrosion over a period of time, and it will be a permanent gas cylinder sitting, it may have milligrams of gas good enough to spoil semiconducting chamber for 1 year. So, you have to be very careful in butt welding. Similarly, in lap weldings, inside vacuum you should have a continuous welding, outside it can be discontinuous weld. This is to create additional strength. This should be for the leak tightness. Weld should be having two purposes, one is strength, joining strength, other is leak tight. Third one I am telling you, which later also I will concentrate on, degassing, then corrosion, various aspects come into picture. These are also talked in high pressure weldings also. There are very good chambers being manufactured by some company for the same welding torch, etc., some shabby looking components. So, you will have to be careful. Corner weldings, this is the correct welding. When two things are joined here, the entire thing is flushed with the welding material, so that no leakage probability and good enough strength, because there is an adhesion this side, adhesion this side. But this type of thing if you do, on one side you may have pockets, the other side strength may not be good enough, and at any time you may end up in accident. Okay. So, you have to be careful when you are doing corner weldings, and when to do lap welding, when to do butt welding, that depends on the geometry, etc., that welders know very well. So, these things you should keep in mind. I repeat, vacuum side welding, full penetration and continuous welding, cleaning properly before and after, and assembling whenever you require with normal components, and bending of these sheet metals in a perfect shape, all these things, finally welder's efficiency. Okay. These things should be, gadgets should be properly designed to hold these materials. Then comes some equipment which are used for welding. well, vacuum industries may not be interested in knowing, because they will purchase welding units. If it is a typical TIG welding, for example, this is well known, most of the laboratories companies will see that high current transformers are there, AC transformers, and TIG tungsten inert gas welding, and that electrode, there is a huge arc that is created because of small gap interruptions. High current suddenly produces a big arc, and this is grounded with respect to electrical voltage, and finally, you will get very good welding. If the materials are allowed to melt, that is one way of welding. Sometimes you may have to add little bit more material by additional rods. All that technology is very well known to most of the welders. But what is not known to most of the welders nowadays is plasma arc welding, where with a high voltage a gas is coming from inside with a shielded gases, and suddenly because of these voltages a flume is created, that is plasma, and finally that plasma touches the jobs to be welded and in a butt joint, and heating takes place, enormous heating, and these are stainless steel with bad conductivity, that heat will be retained there locally, so that it will not be conducted away, and that way you will get very good quality welding. There can be blanketing of inert gases from this gas, so that your oxidation at that hot conditions will not take place. That is true for all welds, you have to keep track of that. Similarly, if you use electron beam instead of a plasma, naturally you can understand that you need to focus them. Unless a focused electron beam is there, it cannot produce good amount of thermal energy. So, these electron beams are first accelerated, and they are produced from some thermionic emission or field emission, and they come towards the anode, and they get diffused electrons, it is cathode ray beams, and they can be focused again by focusing coils, which are nothing but electromagnets. So, because a charged particles can be deflected or focused by suitable design of our magnetic coils, which you can control this focusing by changing the current through that. Sometimes you can create permanent magnets also to reduce the cost, and finally go through an aperture and bring it to a workpiece. And this may be in relatively poor vacuum, this may be a very high vacuum, because you are producing electron beams etc., it requires high vacuum. That is why there is a differential pumping concepts are involved in electron beam units etc. Sometimes all the way it may have to be taken to the atmospheric pressure also, but how do you focus these electron beams, how do you make them available to the beam, it is a big technology by itself. Most of the advanced research institutes are working on electron beam welding procedures. Then laser beam welding. Laser beam welding is nothing but an optical thing. It is in our childhood we might have seen, just keep a lens and light will be focused and paper will be burnt. That type of thing we will do it with a single frequency laser beam. Intense laser beams are available commercially, because laser technology is well developed. There are very fine lasers for eye surgery, there are very high lasers for even Star Wars, okay. There are high beam lasers for creating 3D pictures, very high intense laser beams are available for welding. So, lasers are now, it has become toys, communication technology through optical fibers. So, laser technology is well developed. All that we need to do is with a pulse power supply etc., we simulate, we create a laser beam of a particular radiation and focus it. This time focus will not be electromagnetic fields like this will be optical lenses, and that focused beam is brought to the pieces where there is a butt joint waiting for it, and there will be very good welding. Finally, all these four mechanisms, whether it is a TIG welding, high current suddenly interruption through that and huge amount of high current gets converted into discharge, or a flume coming out of plasma, or an electron beam suddenly focused creating intense, because when electron beam is suddenly stopped, all that frictional energy is converted into thermal energy, or a focused light energy is converted into thermal energy with proper alignments, with beautiful amount of pure argon, inert gas argon blanketing everything. We should be able to get very good welding using these advanced technologies. If these are not required for 10⁻²tor, you can use this. At component level, you can use certain electron beam technologies. So, when to use what technologies, whether it is advanced or not, it is left to the decision of the particular industry or the budget. Okay. Then comes the next thing, which is also very important in day to day life, brazing. I also need not tell you what is brazing, because joining by itself two materials melting together, that is sort of welding. It requires very high temperatures, sometimes more than 1500 degrees type of thing when stainless steel is melted. But you cannot do that for aluminum, unfortunately, because when you are increasing it for welding, aluminum gets oxidized. Aluminum oxide is a ceramic, so it will not be possible. But there are lots of ways to overcome. There is a lot of research going on aluminum welding, but aluminum is a high conducting thing. Thermal energy concentration is not possible on one side, melting point is small, oxidation is a big thing. So, all these three challenges are being worked out by metallurgists and mechanical engineers for good amount of aluminum welding. As and when if it comes out, because of its light weight, it is going to dominate stainless steel, because in vacuum aluminum degassing is smaller. But right now stainless steel is still the dominant thing. So, copper pipes are there in the plumbing works, they are very good, and they are also to be brazed with elbows etc., to get some flexibility in the vacuum systems. So, brazing things are used in dissimilar materials when they have to be joined and using a suitable flux, and it is a costly process, because you require silver brazing rods, you require very good flux, you require a pure argon gas and a very good jigs and a good brazier also, very good brazier should be there. So, all these things are very important, and it is worthwhile spending that much money, because you cannot afford to have welding that place. So, naturally you have to go for brazing, and when it comes to ceramic to metal brazing, such complicated things you have to following certain strict rules with respect to vacuum compatibility etc. And when two materials are having two expansion coefficients, then you may have done, but when it is cooling down it may crack. So, all those things you have to take into account, but brazing you have to clean before to make the jobs, and you have to clean afterwards to remove the excess flux. Otherwise, you will start getting some erosion, corrosion issues. So, if you can take care and with proper understanding, you can reduce the budget, you can make a very good brazing, which is routinely being done in vacuum technology, in small couplings to be joined to the vacuum chamber, which was originally welded. And if it is SSSS, sometimes they do welding, sometimes they do brazing. So, it all depends on your conveniences. If weights are not much, you can just do a brazing, but all should be compatible to the vacuum level. If it is a ultra high vacuum, all welding is better. If it is really extremely high vacuum, monolithic chambers may be better. So, it has to be thought over according to the level of sophistication required. Then comes gluing techniques. These are very elementary technology, like two things we join. Even in our childhood, we stick two things with a gum. Similarly, here we can join two things with a glue. Okay. This glue, there are certain standard epoxies. Every country has got good research institutes and plastics and composite materials nowadays, glues, epoxies etc. We also in India have got CPET is an organization who does lot of things in India to concentrate on plastics, components, ceramics, composites etc. So, those things are now coming to a level where after putting onto joining, the degassing is quite small, strength is quite big. So, for example, the figure shows a small plastic pipe with two end couplings being joined by a small amount of epoxy. The cheapest epoxy available in the market is araldite. It is available in normal shops. Okay. So, you can hardware shops, you can easily purchase and use it, but you cannot use these things if it is higher side of high vacuum. I will not say high vacuum, if it is -4, -5 you can use, -7, -8, ultra high vacuum definitely not. First of all, you cannot use plastic pipes, you cannot even use brazings at some time because of flux and other problems. Okay. So, depending on the level you can do that. So, glued joints are coming up, it depends on the curing temperature etc., but you have to keep track of leaks through that, and if there is a mechanical stress there, you should not apply glue, or you should give a threaded joint so that mechanically it is strong, and add some additional stitches and then apply the glue. So, leak is different, strength is different, and sometimes it can be taken care in the same operation. like welding, etc. So, you have to keep track of all that, but they are out because they cannot be baked. If you bake an araldite thing, it will lose its strength as it becomes powdery. So, you have to keep track, otherwise room temperature stuff for day to day things up to 1 tar type of things, this gluing is a very good technology of joining. I am talking with respect to vacuum systems for pharmaceutical, chemical on one side, metallurgical in the middle side, and suddenly ultra high vacuum in space and nuclear and semiconducting. So, depending on that, you have to decide these technologies. So, as I already told you, you have to clean things better before and after. So, these are various types of cleanings like electropolishing, electromechanical machinings, ultrasonic cleaners and abrasive cleanings. For example, before the abrasive blasting process, it looks like these components, afterwards it looks like this. So, you have to slowly from a very rough surfaces, you have to come to the finer surfaces. Why? Vacuum technology surface area matters. Not only for joining and fabrication, the outgassing will be smaller if the effective area as seen by the vacuum chamber or pumps is less, because specific vacuum outgassing rate into area that matters. So, cleaning is very, very important. Clean technologies, green technologies are the main words nowadays we are hearing. Similarly, in vacuum technology, cleaning is very important. Even the persons should wear aprons before they enter into ultra high vacuum chambers. They should go through a shower room and they should have a drying chamber. They should not use anything. They should not sweat. They should not be in tension. If they get tense, they will sweat, and 1 cc of sweat will create billions of cc at ultra high vacuum. So, cleaning is important, but cleaning agent should not be left before you start operating under vacuum. And after cleaning, etc., I am talking with respect to fabrication, not during evacuation. So, you should keep track of that. All these all 4 are there. Most important thing is initially cleaning with soap solution, followed by deionized water and ultrasonic cleaning to remove the dirt. Later you go for ion etching or chemical etching or various other high tech things, but finally you have to remove the pollution of various parts on the surfaces. They are important for fabricating, welding, as well as they are important in the final assembled state when you will get less degassing. So, you have to keep track of all these things in the cleaning. So, we have seen welding, brazing, gluing and matching things, and also cleaning technologies and advanced welding equipments like electron beam, etc. So, with all these things, with good design that we have covered in the last 3 lectures on chamber design and components we have shown you on various levels, and ultra high vacuums, gaskets, degassings and materials to be chosen, you will be in a position to make things, systems for any application. That is the aim of this particular thing. So, to conclude, welding, brazing, cleaning are very, very important essential techniques in making a ultra high vacuum or high vacuum or vacuum systems. So, you should keep track of all these things. And finally, as I told you, it depends on the welder's experience, expertise. That is very, very important. Cleaning of the components before and after is equally important. That is why I am stressing it again and again. If you do not clean, you will get -7 tar, 3 orders less than the required vacuum. Nobody will be happy. It will be a junk equipment if your application requires 10 power -10 tar. But if it is -3 tar, that is a different style. Chamber should be compatible more to the process chemicals rather than cleaning issues, rather than ultra fine leaks. We did not care, but we have to care there, because micrograms matter there. Here milligrams in the high vacuum, grams in the poor vacuum. For the same pressure rise, allowable pressure rise, micrograms are good enough to spoil the show. Okay. So, TIG welding is mostly used, but ultra high vacuum requires specialized additional welding technologies, though initially use TIG welding, but when you use TIG welding, sometimes it may create dirt and welding can be dirty. You should keep track of it. Even though it is not cost effective, you may have to use advanced welding technologies, because final products are much more costly, like IC chips, etc. So, one time investment, no problem. Joining dissimilar materials, normally brazing is used, and welding is always preferred in the vacuum side. That is why I am again referring, otherwise it will create pockets.
which are very dangerous. A small pocket can give you 10 years problem not to get vacuum. I am just exaggerating, it may be 1 year. Okay. In the next class, we will discuss more important issues like degassing, leak and other assembling strategies of components, when to do that, and day to day life, how do you check the quality of vacuum systems, so that its longevity is more. All these issues we will discuss in the next class after completing metals, alloys, materials, and then components, then chamber designs, now welding fabrication technologies. All these particular issues are done. Now we are in a position to do the system design. So, let us go to that aspect now of overall system design with respect to fabrication technologies. Thank you very much.